Okay, so we are let's see what are the, so we are looking after the organic chemistry, and now we need to understand what are functional groups. So they are saying the functional groups are basically atoms, radicals, or basically group of atoms or bonds which are going to be added to this particular, when added to this particular group of hydrocarbons, they will have a completely different behavior of their own. So they are the one which are going to define the structure of organic compound or confer to it the characteristic properties of certain particular nature. So that's why they are called as functional group, because they are going to change the function of that particular compound. So when you are adding some OH to a thing, it no longer remains an hydrocarbon, it becomes an alcohol. When CH or O is added, it becomes an aldehyde. So this way you will find that the function or the properties of that particular substance is going to change by addition of this such thing. So that's what we need to understand now, and that is the functional groups. So the first thing about the functional group, what we can see is the one which are going to be added are the hydroxide. So we have over here the first one as hydroxide. Okay, so hydroxide are basically, it is OH group. The functional group over here is OH. So OH is something which is going to be added to that particular compound. Like for example, if it is like this, that C और यहाँ पे है सब जगह पे H, H, H and H. When one of this H is getting replaced by OH, that means it is becoming like this, then this is the example of an hydroxide. This is called as, this was originally methane, it has now become methanol. Okay, methyl alcohol. So that's the difference over here. So OH is going to be replacing one of the hydrogen atoms. So we see that OH is like this, and they are, that's the structure over here. The structure of this O is always that there will be a single bond with O here and H here. So this C will be here. So it will be like this. So this is, and these hydroxide are called as alcohol, and they add a suffix. Okay, they add a suffix to the compound as OL. The suffix added to L is OL. So that's why, for example, over here it is going to form into methanol. Okay, methanol. So methyl alcohol or methanol is going to be formed when you are forming this particular thing. The next one are aldehyde. Aldehyde. The aldehyde are CHO. So CHO is something like this, wherein it will be C like this and a double bond O here and a single bond H here. So if this is the structure like this, then it is an aldehyde. So aldehyde will be the one which will be ending with Al. So what will be ending will be Al. So this will be forming into methanol. So in fact methanol cannot be there. Yeah, we can say it as methanol. Yeah. Okay, methanol. So methanol ke badle methanol. So that will be something like this. So that is the alkyl group or aldehydic group, aldehyde, CHO. The next one is carboxylic acid. So carboxylic. So it is carboxylic acid or carboxyl group. So carboxylic or carboxyl group is the one which will be C double OH. Okay, COOH. The structure over here will be C with a C here and a double bond with a C here and a single bond and a single. So you can say something, a combination of these two. This will be the one which is called as carboxylic acid. So the suffix which will be added over here will be OIC acid. That's why it will be methanoic acid. Methanoic acid. Okay, this is the example of carboxylic acid. The next one over here is ketone. Okay, the ketone are the one in which there is a C के ऊपर एक double bond, एक single thing and double bond in a C in between. So when it is like this over here, it is called as a ketone. So that is double bond O. So yeah, the formula is the same thing, and is there will be a C over here. And so in a branch, if there is a O which is there like this, then it is a ketone. So that will be always like methane 1. So it is going to be giving you a suffix as 1, which will be like methane. Methane 1 तो नहीं होता है, but yeah, we can have it as probutane 1. Okay, that is ketone. The next one is ether. Okay, so ethers. Now some of the things which I am writing over here are not there in your textbook. I am just trying to find out that because they are not given this thing in your textbook, but they are important, and I don't know why they are not present over here, because they do ask questions related to this, or it is given but in a just in the nomenclature part. They are not given you in detail about what exactly they are. So that's why it is important for you to understand right away that what are the different functional groups. So ketone will be like this, and then finally are the ether. So ethers are the one in which there is a O in between the two compounds. So two carbon के वहाँ पे एक O है, so it will be like this. So you can see it will be always be like this. The C carbon will be there, then there will be O, and then again C over here. So if this is the condition, then these are ethers. So they are going to be such that they will be given the name as whatever is over this side and whatever is this side. So it will be ethyl, so dimethyl ether, वैसे करके नाम होगा. So nomenclature when you are learning it, we will be able to tell you much about it. But these are the one, it doesn't have a prefix or a suffix, but they are the one which are ethers. So ethers are just written as ethers. So they are the ethers. The next one over here are the halides. So halides are the one which are going to be like chlorine, fluorine, bromine, iodine. So these are the one which are just going to be कि कोई सी भी कार्बन के उसमें हाइड्रोजन को रिप्लेस करके they are going to be some chlorine over here. So if hydrogen is replaced by a halogen, it will be like this, and they will be having a prefix. So it will be a prefix which will be as chloro, bromo, fluoro, iodo, and so on. So yeah, I just missed it. Fluoro आएगा, bromo आएगा. So fluorine के लिए fluoro and bromine के लिए bromo. So they will be given this particular kind of the prefix, not the suffix. See, in this case, they are the suffix, that is methanol, methyl, और ऐसे करके वो नाम में end में कुछ आता. That is the, so these are suffix, whereas these are the prefix. So prefix will be like that. And of course the alkyls are also a kind of alkyls, that is nothing but CnH2n minus plus 1. So these are alkyls जो है, like it could be like CH3 or something like that. So it will be again a prefix of methyl or ethyl or butyl, ऐसे करके उसका prefix आएगा. So that will be methyl ether, methyl propane, methyl butane, वैसे करके नाम आएंगे उसको. So that will again a prefix. So in prefix there are two ones. One is the halides and the alkyls. Alkyls and the halides will be in the prefix of the nomenclature, whereas the others will be having it in the form of a suffix. So we saw that the functional group, that is hydroxyl OH, it is CH3OH, which is methanol. Ce2H5OH will be ethanol. Aldehydic, that is CHO, which will be HCHO will be methanol. CH3CHO will be ethanol. Carboxylic acid CHCOOH, which will be HCOH, will be methanoic acid, which is also called as formic acid, and CHCCOH is ethanoic acid, or is acetic acid. Halides will be CH3Cl, that will be chloromethane or methyl chloride, or C2H5Br will be bromoethane or ethyl bromide. So these are the different functional groups which are present. Now we see some of the examples of the isomerism in organic compounds. So the term isomers are organic compounds having the same molecular formula but differing in molecular arrangement or in structural formula. So when the structure is different but the molecular formula is the same, we call them as isomerism. So that is what I explained to you earlier. So the characteristics of isomers are phenomena called isomerism, properties, similar chemical properties, differ in physical properties. Properties are of isomers of the same homologous series. So isomers will be having the same homologous series जो रहेगा वही property रहेगा, but otherwise the chemical properties will be similar but the physical properties will be different. Now the number of isomers, it increases with the increase in the number of carbon atoms. If the carbon atoms are more, the different types of isomers which will be formed will be more, and if more number of isomers will be formed. This is quite easy because the branching can be of different natures and different forms. So that's why as the number of isomers or number of carbon atom increases, the number of isomers also increases. Like for example, C4H10 has got only 2 isomers, whereas C5H12 has got 3 isomers. And if you go for further thing, they may have more number of isomers. Now we come to the types of isomerism. So there are basically, we can say there are 5 different kinds of isomerism, but we are going to study only 2 of them. The first is chain isomer, second is position isomer, functional isomer, metamorphism, and tautomorphism. It is due to the difference in manner of linking of atoms. So how the linking of atoms is going to take place, depending on that, there will be these kinds of isomerism. So when we see about the isomerism, the first one is a chain isomer. A chain isomer is due to the difference in arrangement of the C atom in the chain. So let's see what do you mean by chain isomer and the position isomer. Okay, what we see first is the chain isomer. So we can see over here that it is a difference due to the difference in the arrangement of the carbon atom in chain, and position isomer is a difference in the position of functional group or double bond in a particular thing. So and then there is a stereo isomerism, that is, for example, geometrical isomer due to the difference in arrangement of atoms around the double bond. So these are certain kind of things which are there. Of course, stereo isomerism is just for reference. It is not in the syllabus. So we first see the examples of the chain isomer. So we can see the first one. We take it as the compound. What we take it is isomer of butane. So butane is the common name is N-butane, and the chain isomer is isobutane, and the IUPAC name will get to know that thing, butane. And so let's see what is butane and isobutane. So butane is nothing but C4H10. So the first one could be just the normal N-butane. So N-butane will be just like 4 C's all in one line, and then this is the H over here. This gives us a normal structure of butane, which is N-butane. But the one which is isobutane will be such that this is not in a single line, but it is in a form of a branch. So if it is in the form of a branch, then the formation will be like this. So this will be the formation over here. Accordingly, this is called as isobutane. Okay, this is called as a isobutane, and nomenclature wise it will be called as 2-methyl. This is the methyl functional group, CH3, right? This is one chain, so it will be 2-methyl. This is, now it is the chain will be of 3, that is why it is called as propane. So propane. Now how do we get this 2 and all? I'll tell you when we've seen the nomenclature part. So just for the sake of writing, right, I am writing this particular name which is called as the IUPAC or IUPAC name. So IUPAC name is butane, which is 2-methyl. This is IUPAC name is butane, and for this the IUPAC name is 2-methyl propane. These are the IUPAC names. So this is the IUPAC names. Similarly, we can have one for the pentane. So pentane will be having 3 isotopes. So pentane is C5H12. Okay, C5H12. So the first one will be normal pentane. So it will be C5s over here, the 5 C's like this, giving us the H over here. Here, all these H. So this gives us the normal pentane. This is the IUPAC name, which is pentane, which is also called as N-pentane. So N-pentane. The next one will be isopentane. So that is isopentane will be C, but 1 C like this. So this gives rise to the structure. So this, what you see over here, is C4s in a row, but 1 C is in a branch. That's why this is isopentane. The IUPAC name will be 2-methyl butane. Okay, that will be 2-methyl butane. The third isomer in this case would be that this C are just like this and 1 C on each over here like this. So this is going to be H, H and H here, 1 H, 1 H and 1 H here, 1, 1, 1 here, and accordingly 1 H, 1 H and 1 H here. So this is called as neopentane, and IUPAC name to this will be 2,2 dimethyl propane. How do you get this? Later in nomenclature. But right now you can see that these are the 3 isomers of pentane. Pentane के 3 isomers है. That is, one is a single row, single branch, single, no branches at all. Second one is 1 branch, and here 2 branches, one up and one down. So that's why this is neopentane, this is isopentane, and this is normal pentane. Okay, so you can see that these are how it is going to exhibit the chain isomer. The chain isomer will be based on this way. The next one we see will be the position isomer. So next is position isomer. Now position isomer is normally will be seen only when it is a unsaturated hydrocarbon, that is alkene or alkyne. So the position isomer, it will be seen majorly in alkenes and alkynes because the position will require double bond. So depending upon the position of the double bond, you will be having this kind of a thing. So we have over here the first one as butene. Now butene is nothing but C4H8. So when it is butene over here, it will be the first kind of a thing will be C4. So there will be 4 over here, but it is butene. So one of them will be double bond like this. And there will be H all around. So we can consider this as condensed form. So it will be CH3. Here it will be CH. Here it will be CH. Okay, and here it will be CH3. So CH3, this will be CH2, CH and CH3. Okay, this is going to be 1-butene. Now the same one, it could be such that my double bond is not here but it could be here. So it will be CH3, single bond, CH2, single bond, CH2, double bond, CH. Okay, so it could be like this, or CH3, CH2, CH2, CH2. So you can see over here that this is a possibility that double bond instead of being here, it could be here. So the different positions of the double bond will give rise to different position isomers. So position isomers will be the one in which both will be like this. And accordingly, there could also be the one which is called as a geometrical isomer, wherein you will find that the only thing is that the position of the CH3 is different. So you can see over there, it is not in your syllabus, so need not worry about it. So geometrical isomer, they are given the example of C4H8 only. So they are given here the example as C and then double bond like this, and then you have got like this bonds. So one will be CH3 over here, but CH over here, sorry, only H over here, yeah, no CH of course. And then you are having a CH3 over here and over here H. This is the 2-butene CIS. Another one is the C double bond C, and then here it is CH3, and here it is H, and the next one here it is CH3, and here it is H. So the position of CH3 over here, or it is here. So this is how you are going to change the different locations, and that's why geometrically they are forming different kind of isomers. So that's why they are called as the geometrical isomers. So isomers of alkyne exhibit mainly position isomer. In case of so these ones are the one in which it is not only this but also the chain. The chain over here is like this, where the chain over here is like this. So the chain is also in a different form. So that's why it is a chain as well as the position isomer. Whereas in case of the alkynes, it will only be in the form of position isomer, because if you have a butane, so it will be just like CH3, single bond CH2, single bond, triple bond CH. Okay, so this will be the one condition. Other condition will be A bond with the बीच वाले लिया तो CH3, single bond C, triple bond C, single bond CH3. So this will be the position isomer in case of the alkyne. So this way, depending upon where is the position of the double bond or triple bond, the isomers of the compounds will be different. So that's what we call it as the isomerism or isomers of the different compounds. So they are given you the examples over here of butane and one butane and two butane, or one pentane and two pentane. So this is just that the position of the isomer, a triple bond, is different in both the cases. Now we move on to the next but the most important part of this chapter, that is nomenclature. Important display because it is normally a 5-mark question. They will ask you 5 questions and ask to name these particular compounds, or they give the names and they ask you to draw the structural formula of that thing. So that's why very important nomenclature. So we'll take it in the next video.